मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P²CB, जिससे फिजिक्स पे होगा डबल फोकस। डोंट जस्ट मेक इट योर लास्ट ट्राई, मेक इट योर बेस्ट वन येट। जॉइन इन्फिनिटी लर्न टुडे।
Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn. How are you all doing? Can you all able to see me? Can you hear me? Just give a thumbs up and fire emoji in the chat box. Hi Furkan Khan, good afternoon. How are you all? So today we are going to discuss about the structure of atom, quantum mechanical model. So based on this quantum mechanical model, definitely you are going to get one question from this quantum number, the possible quantum numbers. And you all can see, hi Bhargav, how are you? So today, before going for the session, I just want to say we started atomic structure, and in the atomic structure we discussed about the Planck quantum theory and photoelectric effect. Later on we discussed about the Bohr atomic model and hydrogen spectrum. And we are going to discuss today about this post-Bohr model examinations and this quantum mechanical approach of the atom. Right, my dear students? So let's see. Yeah. See, please confirm you all able to can see me now? Right. Now let's see, before going for this session, just I want to say this session is hopefully helpful, and it is going to be for the NEET droppers and those students preparing for your NEET examination. Maybe you are in 11th standard, 11th standard ka topic hai, and the 12th standard, and you are going to get one sort of revision and NEET dropper ke liye. You all done with NEET 2025 where you got your examination, and if you do well, all the best, and if you are not able to do, we are from Infinity Lane by Sri Chaitanya Academy. We are coming up with Atreya program. We will change your mindset from I didn't do to I will do it. Yeah, it is required for JEE as well, Bhargav. And I didn't do to I will do the crack your NEET examination. Infinity Learn by Sri Chaitanya Academy introducing Atreya, India's most powerful NEET preparatory program. And you all know physics is the nightmare for your NEET examination. 2025 physics paper is slapped you like anything. For that we are coming up with a great program, and India's most powerful NEET repeaters program, that is P²CB, physics twice a day and chemistry and biology along with that. And for that you see, revolutionizing NEET preparation with P²CB program, and double focus on physics with chemistry as well as biology. And enroll now, the description box link is available. And I am going to explain you the program details here. Program structure, batch commencement, already batch start ho chuka. And the classes are going to be from Monday to Saturday. And 1 hour 30 minutes ka hai class. And 3 classes per day. 2 concept class, usme ek physics class ka. And 18 classes per week, and you are going to have double practice session for physics. Right, beta? Now, and let's see here, interactive classes by expert faculty, 465 classes for the total syllabus coverage of 11th and 12th. And after the class, you will be getting notes in the PDF form at the end of the session. And also batch size for the practice class is going to be 20-25. So this is outstanding, because when you have a limited number of students with the expert faculty, you will be having a discussion with the faculty, customized doubt clarification can be done. So this is very important, and link is available in the description box and pinned messages, and you can back to the preparation and you can prepare it well. And we can say once you did today NEET 2025, you can predict your college and the score and the rank. For that also we have given a team, and the team is working on the link, and you just fill the link and you're going to get the details. Okay, so promotion is over, my dear students. Let us start a quantum mechanical model. So let's start here. Pathway to quantum mechanical model. So far we studied Bohr's atomic theory. In this Bohr's atomic theory, electron is revolving around the nucleus in a definite path called orbit, and this path is well defined, and electron is precisely present there. And the quantum mechanical model is completely different. Electron was considered to be a particle as far as the Bohr is concerned. Now it is said to be electron has a dual property, mean to say wave property as well as an electron particle property. So why this is happening so? And this is explained by important developments in this pathway to quantum mechanical model, dual behavior of the matter and Heisenberg uncertainty principle. Heisenberg uncertainty principle is the footholding step for the quantum mechanical model. This quantum mechanical model is said to be the modern atomic structure. So up to Bohr atomic model, the atom and the particle, electron is a particle, and that is a classical atomic model. After Bohr atomic model, we have the Heisenberg uncertainty principle, where and the duality of the matter is also considered. So where it is seen that the electron is a particle as well as a wave. So it is called as a modern atomic model. We are going to discuss that thing in today. So students, let's talk about the pathway to quantum mechanical model. So Bhargav and Furkan Khan, all the students who are online, you can have the live interactive session between you and me. You can ask a doubt during the session. So let's see here. De Broglie. So De Broglie concept, dual behavior of the matter. French physicist De Broglie in 1924, he states that matter has both particle as well as a wave nature. I want to say, if the electron is going like this, it has a wave nature, three-dimensional wave nature. I have that animated picture as well. I just want to show it, Bhargav. And just like light, which is described as a both stream of photons and electromagnetic wave, electrons which were thought as a particle also exhibit wave nature. It is alternating. Yes, every moving particle, maybe electron, maybe cricket ball, has its wave nature, and the wave nature and as a particle nature, it is shown in that way as well. How much wave nature, how much particle nature, it varies. For the lighter particle, it is a more wave nature, and heavier particle, it has a less wave nature, my dear students. Let's see here. De Broglie says that, De Broglie gave the relation between the wavelength, so lambda, and the momentum of the particle P of a material particle, as lambda is inversely proportional to its wave, its momentum. So you can say lambda is equal to h by p, where p is equal to mass into velocity. P is the wave momentum, lambda is equal to wave length of that moving wave, and h by p. H is called Planck's constant. Its value is going to be 6.625 into 10 raised 20 minus 34 joule second. So is that clearly visible? Is that clearly visible, my dear students? Okay. Now, De Broglie hypothesis, De Broglie prediction was experimentally verified by Davisson and Germer, who observed that the electron beam undergoes diffraction, a phenomena characteristics of waves. So a beam of helium atoms were moved. Yeah, you can see here. So I just want to say, X-rays are just taken a crystal, and X-rays are allowed to is allowed to scatter over here. So they found the diffraction pattern, and the diffraction pattern is same just as with the same crystal is diffracted. The same crystal is diffracted with electron, beam of electrons. So the electron is also shown the same scattering pattern. So this is the Davisson-Germer experiment. In this Davisson-Germer experiment, it is shown that the pattern is same when you use the X-ray as well as an electron, which indicates that the behavior of the electron and the behavior of the X-ray is same, and which provide the wave nature as well as a particle nature. Right, beta? Any doubt, my dear children? Bhargav? Furkan Khan, right? Okay, now let's see here. A beam of helium atoms move with a velocity of 2 into 10 power 4 meters per second. So this is the velocity, 2 into 10 power 4 meters per second. And find the wavelength of the particle constituting the beam. You are asked to calculate this. And the mass is going to be 4 AMU, 4 into 1.66 into 10 power minus 27 kg. Hi, Millis, tasty food, of course. So the lambda is equal to h by mv. Mass into velocity, that is going to be 6.626 into 10 raise minus 34. And the mass is going to be 4 into 1.66 into 10 power minus 27. Into velocity is going to be 2 into 10 to the power of 4. So it is going to give its characteristic, the wavelength of this, and it is going to get the answer in the meters. So like that simplified version of the questions, you can solve it, and the unit conversion is also very important. And moving ahead, so de Broglie equation of the kinetic energy. So when the particle is moving, it has a wavelength and it has a momentum. The momentum and wavelength are inversely related. When it has a momentum, it has a kinetic energy as well. So the kinetic energy and the wavelength is given as lambda is equal to h by mv. Lambda is equal to h by root 2 k e m. So this is the formula to calculate the kinetic energy of a moving particle. H is a Planck's constant, and the kinetic energy of the moving particle is Ke, and m is the mass of a particle. I just want to say lambda is inversely proportional to its kinetic energy. So you can say lambda 1 by lambda 2 is equal to root over kinetic energy 2 by kinetic energy 1. Got it? And if a particle is moving, the kinetic energy is equal to QV. So I just want to say lambda is equal to h by root 2 QVM. What is this? If a particle at rest, if V voltage is given, the particle has a charge Q, so it has a kinetic energy. The kinetic energy is going to be QV. Q stands for the charge on the particle and V stands for the accelerating potential. And it is going to be m is the mass of the particle. Lambda is equal to h by 2 QVM. Okay. And we can calculate it for electron, you can calculate it for alpha particle, you can calculate it for proton as well. So de Broglie equation for kinetic energy, that is given for an electron, wavelength for an electron is going to be 12.3 upon root accelerating potential. So that you are going to get wavelength in angstrom units, otherwise 150 upon root voltage, and it is also the same formula is given in the same way. So you can say here this conversion of these wavelengths are important, this conversion is important, and I can say lambda is equal to h by mv. So I just want to say mass of the particle increases wavelength is going to be decreased. Got it? And these ratios and the calculations are very, very important, my dear students. You are going to get one question from the NEET examination based on this logic, and this particular logical oriented questions can be getting the modern physics, and physics में भी इसका फायदा उठाने की कोशिश करो बच्चों. Let's talk about what have the de Broglie wavelength equation. Lambda is equal to h by mv beta. So if you see a cricket ball, let's say mass of the cricket ball is 150 grams. Let us say it is moving with 25 meters per second. In reality, when wavelength is calculated, lambda is equal to 6.6 h by mv, 6.626 in 10 power minus 34 upon 150 into 10 cube and into 10 power minus 3, okay, and into 25, you are going to get 1.767 into 10 power minus 34 meters. So this value is too small value, and this value has not at all significant. When you talk about the electron, mass of the electron is 9.1 into 10 power minus 31. Velocity of the electron is equal to 2 into 10 cube, and lambda is equal to around 10 power minus 6. You are going to get 364 nanometers. At the level of electron, this value is significant, and this value is significant. And this value is not significant. So what I want to say, de Broglie theory is a de Broglie, but actual pronunciation is going to be de Broglie, and de Broglie theory is true for any moving particle, but it is significant for small particles like electron or proton and alpha particle, while it is insignificant or not significant for bigger particles like cricket ball, aeroplane and all. You understand the application of this de Broglie wave equation? Got it better? Any doubt? Yes. If you have any doubt, please let us know. Yes. So let us see the detailed version of the electron as a wave. So on what basis it is helpful for the de Broglie theory in the structure of atom? You know, the electron revolving around the nucleus, according to Bohr it is said that it is moving like this, but according to de Broglie it is said to be circular standing wave around the nucleus like this. In this n is equal to 1, it is going to make it like this. In its next shell, it is going to make it like this. So electron is a standing circular wave. Yeah, it is about the behavior of light only. It is just it is behavior of light only. So when this is revolving, electron is revolving around like this, its circumference of the circular wave mode is going to be 2 pi r is equal to n lambda, where n is equal to integer. It indicates the number of waves made by an electron in a complete revolution. Okay, so that also it is said that according to Broglie, lambda is equal to h by mv. So this can also be written as lambda is equal to 2 pi r by n. So this is the 1 and this is 2. So h by mv is equal to 2 pi r by n. Got it? Now on rearranging, so mvr is equal to nh upon 2 pi. Again angular momentum is quantized. Again angular momentum is quantized. So Bohr said that mvr is equal to nh by 2 pi. This is the only point given by the Bohr, and based on mvr is equal to nh by 2 pi, the total atomic structure of the Bohr atomic model is explained. And Bohr could not explain, yes, mvr is equal to nh by 2 pi, that is fact. And on what basis it is fact is not explained by Niels Bohr. But this is explained if you take the electron as a wave. This is an outstanding point made by de Broglie. And this electron as a wave, just like a light. Okay, Billies? Now you can see electron is a wave. So when the electron waves are in phase, n lambda is equal to 2 pi r, where n is the number of waves made by an electron in a Bohr orbit. And it is equal to 2 pi r is equal to n lambda. 2 pi r is equal to n lambda, and lambda is equal to 2 pi r by n. Also, according to Broglie, lambda is equal to h by mv. Dear children, and these equations are equated to pi r by n, that is 2 pi r by n is equal to h by mv. On rearranging, it is going to be mvr is equal to nh by 2 pi. So duality of the matter is explained over here. So what is the actual essence of this duality of the matter? I will show you here. Okay, look at this. Dual nature mean to say particle nature. If it is a particle nature, when the electron or any particle is moving, energy is equal to mc square. And it is a wave, according to Max Planck, energy is equal to hc by lambda. है ना? hc by lambda. You see energy of a particle, energy of the wave, and these two are energy parameters, that is equal to mc square is equal to hc by lambda. So you can say this is mc is equal to h by lambda. Lambda is equal to h by mc. C is the fast moving particle. So the range of electron velocity is 2.18 into 10 power 6. Light velocity is equal to 3 into 10 power 8. So the energy, the velocity of the light and velocity of the electron is nearly the same. Not exactly same, no? Just 100 kilometers farak aata hai. So that I just want to say C is nothing but the velocity. You can say lambda is equal to h by mv. So like this is a very important. So this is how duality of the matter is correlated, my dear students. So learn the subject from Infinity Learn NEET YouTube channel and learn the things like this only. Okay, now talking about a question, number of waves made by an electron in the fifth Bohr orbit of hydrogen atom are. Answer. So this is the multiple choice question you studied so far, and I want you to give the answer like this. You tell me. Yes, very good. So I am expecting an answer from the students who are online. Bhargav, Millies. So you have a tasty food. I want to come and eat the tasty food. Okay. So there is a trick. I just want to give you simply number of waves made by. Number of waves is equal to shell number. Shell number. You can see these previous slides. You can see this is the previous slides. Electron is making a wave like this in the phase. So how many waves it can make? It depends on the number of the shells. So here going to be fifth Bohr orbit. It is going to be fifth Bohr orbit means it is going to be answer 5. Option B is going to be the answer, right? Any doubt? Any doubt? Exactly, your answer is correct. your answer is going to be correct. Okay. Now, what is Heisenberg uncertainty principle? You can find the position of the electron. Maybe you can find the momentum of the electron. Heisenberg said you can't find these two simultaneously. That is called Heisenberg uncertainty principle. Werner Heisenberg, German physics, 1927, stated uncertainty principle, which is consequence of dual behavior of matter and radiation. It states that it is impossible to determine simultaneously the exact position and exact momentum of the electron. I wanted to say, let us see how do you identify the electron. Let us say electron is revolving in n is equal to 1 and it is the nucleus, okay, and it is going to be n is equal to 2. So, to visualize the electron, I just want to use a beam of light to identify the electron. When the electron is revolving like this, like this, like this, a beam of light is going to strike this, a beam of light is going to strike like this. Okay. So, I wanted to say you need a beam of light. This light should be smaller than the size of the electron. So that what happens, we need a small wavelength. So you know that energy is inversely proportional to the wavelength. So if the wavelength is very small, it is going to be high energy. So actually if the electron is not there, it is going to be detected like this. It is going to be detected like this. So detector will be placed here. The moment electron comes here, it is going to be reflect like this. So that a detector is going to detect the electron from here. So by applying physics, you can say the bond angles of incident and reflections, you can calculate the position, locate the position of the electron here. But that is expectation. But reality, what happens? This electron is going to jump from one place to another place. Where it is jumping also we don't know. How much energy is taken we don't know. So you can locate the position of the electron, but you are going to get uncertain values where the electron is gone. So you can't determine the position of the electron because electron absorbs that energy, it jumps away from the atom or within the atom somewhere we don't know. So its angular momentum is something over here, angular momentum is some other thing over here. So angular momentum, I mean to say momentum and velocity. So position you want to do it, momentum is changing, and momentum you want to do it, position is changing. So that is not due to lack of a proper experimental equipment, rather it is by principle. You want to do its position and momentum detection accurately, simultaneously it is not possible. That is said to be in Heisenberg uncertainty principle, my dear children. So let us go ahead with this more details. Here the principle optics that works here. So if the position of the electron is known with high degree of accuracy and its momentum is going to be uncertain, it is said that delta x dot delta p should not be less than, can be equal or greater than h by 4 pi. Okay. So delta x is equal to uncertainty in the position, uncertainty in position, while delta p is going to be uncertainty in the momentum. Delta p is going to be uncertainty in momentum. And you can also say delta x and m delta v is should not be less than, can be equal or greater than h by 4 pi. Why m is not given as a delta? Velocity can be uncertain, position can be uncertain, mass cannot be uncertain. That is the reason why m delta v is written. So, if the position of the electron is known with high precision, so if position is known certainly, is known, calculated certainly, accurately, I just want to say. So, it is delta x is going to be 0, right? Its delta x is going to be 0. If delta x is going to be 0, delta p is going to be, should be h by 4 pi and delta x, that is equal to h by 4 pi into 0. Anything divided by 0 is going to be infinite. So, delta p is greater than infinity. Mathematically, is this value is valid? You all tell me, is this valid? Of course, it is no. So, I wanted to say certainty in one parameter introduces uncertainty in another parameter. Are you getting or not? Clear? That's fine. Okay. So, let us see here the details of this. Heisenberg uncertainty principle. Mathematically, delta x dot delta p should be equal or greater than h by 4 pi, and delta x dot m delta v is equal to h by 4 pi. Delta x is uncertainty in position, delta p is uncertainty in momentum, and delta v is uncertainty in the velocity, and m is a mass of a particle, and h is going to be Planck's constant. It is going to be 6.626 into 10 power minus 34, my dear children. Okay. If you have any doubts, please let us know, students. Okay. So, quantum mechanical model of the atom, talking about wave behavior of the electron, which requires Schrödinger wave equation is explained. Before going for the Schrödinger wave equation, if this electron is considered to be a wave like this, as we discussed it so far, this is the electron behaving like a wave. So, that wave has the peak of the apex is called as the amplitude. Psi is said to be amplitude of the electron wave. Now, in this picture we can see, dear children, psi value is going to be 0 over here, psi value is going to be negative over here, psi value is going to be positive over here. So, psi value can be a negative or a positive, can be 0. So, in the probability functions, the negative values are not taken, either 0 or 1 is taken. Heisenberg uncertainty principle says it is impossible to exactly say the location of the electron. So, we can use the mathematics and the probability and differentiation concepts, and a wave mechanical model says electron probably may present in one place, probably, not accurately. So, this probability is a function we can say by using a psi square. So, psi square is taken, psi square is always a positive function, this is a psi and it is a square. So, this psi is a wave function and it gives the amplitude of the electron, while psi square is a square of any number is going to be positive, is going to be here in the wave probability function. So, psi square can never be negative, it could be 0 or a positive, while psi is a wave function and it is gives the amplitude, it could be 0 or negative or a positive, it has no physical significance. So, in this three-dimensional wave, electron can be characterized in this axis, and in this axis, and electron can be identified by using a Schrödinger wave equation, that is given as a wave equation describes electron in a motion as a three-dimensional wave traveling in electric field, and this around the positive nucleus, this Schrödinger differential equation given as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square of plus 8 pi square m by h square of E minus Pe of psi is equal to 0. So, what you are going to talk about this psi, and this is the Schrödinger wave equation. This Schrödinger wave equation should solve. This is the mathematical equation. This mathematical equation is going to solve for psi along with x axis, along with y axis, along with z axis. Okay, that is the actual meaning of this Schrödinger wave equation. Let us say a Cartesian coordinates x, y, z along the x, y, z Cartesian coordinates. So, these are the x, y, z Cartesian coordinates. So, here it is x axis, y axis and z axis. So, not seen, not visible. Yes, axis only, na, doesn't matter if it is visible or not. Now, this is your nucleus. By taking the radial probability and by taking the angular probability. Radial probability takes you finding electron with certain distance from the nucleus, that is called radial probability density, and finding the electron with a certain angle between the axes is called angular probability. Hi, Virat Kohli, solution of Schrödinger wave equation are always positive. We have eigenfunctions beta. Okay, so in that eigenfunctions, this Schrödinger wave equation is going to give the solution for n number of solutions, and a majority of the solutions has no meaning, as useless values, and we are going to take the condition, and that condition solutions only we consider, and we can take the probability of finding of an electron is like this only. Now we understand? Clear? Sorry. So, those values are called eigenvalues and condition for the wave solution also I just want to give you. For NEET examination itna खास बात नहीं है, and again you solve it, you may get a probability finding of electron maybe like this. So, like that this Schrödinger wave equation is solved for multiple times. So, when you do it, you may be getting like this. So, you are solving for the hydrogen atom. So, probability is getting like this, sir. So many solutions you got it like this. So, these are the various probability chances of finding the electron. That is the image of the hydrogen atom drawn on the graph paper. It is a three-dimensional spherical structure. So, this is called S orbital. So, if somebody can say, ask you, can you see the atom? You can't see the atom, but its image can be mathematically drawn like this. You love it? Along the x-axis, along the y-axis, along the z-axis. Got it? So, for that we need, if you want to say the electron dot like this, electron dot like this, you need a radial probability density. You need an angular probability density. And the angle between here, it is going to be theta, and angle between these two is going to be angle pi. That is called radial probability and angular probability. Are you getting or not clear? That's fine, fantastic. And based on that, we have to discuss about the shapes of the orbital also. So, that I already explained here, boundary conditions. As you asked, psi values. So, a subshell has no direction. Yes, of course, I am going to show you the animations also. So, what are the conditions? Hi, Virat Kohli, You have taken the cup yesterday, day before yesterday. Yesterday's celebrations are also over. Now let us see the conditions. You asked the solution of Schrödinger wave equation is always positive. These are the conditions. Right? So these conditions require some multiple choice questions in the examination, my dear children. So wave function must be finite and continuous. There should not be any discontinuous values. And it must be a single valued. At a given point, there cannot be more than one value for psi. It should be a single value. And psi must become a shell at the large distance from the nucleus in order to depict that bound stationary state. It cannot be oscillating here and there. Where the electron is held close to the proton. When the electron is said to be infinite distance from 2-3 kilometers distance from the nucleus, such values are imaginary values. Okay, but real time values you can take. It is normalized, that is integral of minus infinity to plus infinity psi square dr is equal to 1, and it should follow this. Okay, this is the basis of the quantum mechanical model of the atom. Got it? And moving ahead, the values of psi which are valid are called eigenfunctions, and the values of a corresponding the values psi values are called eigenvalues. And behaved wave functions were found to be characterized by a set of 3 quantum numbers: principal quantum number, magnetic quantum number, and azimuthal quantum number. Just a minute. And spin quantum number, you know it, but it is not related to quantum mechanical model, and it has the quantum mechanical model has its boundary conditions. You have to follow that boundary condition as well. And you can see, okay, so shapes of orbitals. I just want to show you the shapes of orbitals, like boundary surface diagram of a constant probability of density of different orbitals gives here boundary condition, mean to say here, here and here. So this is the boundary level diagrams. Just see x axis, y axis and z axis. This is the nucleus. So we have radial probability d, that is called 4 pi r square dr psi square. I just want to say the electron is existing here with certain differential, this is dr psi square, and this is what is called as radial probability density. So for here, if you talk about the 1s orbital, so d is the and radius, and from the nucleus it is going to increase and decrease. And this is the point where it is the maximum probability of density is seen. This is the 1s orbital of the hydrogen, my dear children. This is very, very important. So spin quantum is only to separate 2 electrons in the orbital given by a Pauli. Is that right? It means a spin quantum number only to separate electron in the orbital given by Pauli. No. Spin quantum number signifies the spinning of electron about its own axis, beta. Okay, and if you could able to calculate the distance is maximum, probability density is a maximum from the hydrogen nucleus is going to be a naught. So that is going to be 0.529 angstrom units. Mathematically it is correlated. So what Bohr atomic theory is said, it is valid, but the way Bohr explained has its limited. Understand, this is very, very important, my dear students. So let's see this boundary diagram. So you can see probability of the electron with certain distance is called radial probability density. and you can see the angular probability also. Yeah, let's talk about the orbit and orbital. The probability of finding of electron where it is maximum, at least 95%, is called as orbital, and the path in which the electron is revolving is called orbits. That is psi. It is pronounced as psi. Okay, psi. You understand? And it is limited to only single electron species. Yes, all the atomic structures is what we studied is hydrogen like species. Okay, and the shapes of orbital, s orbital. S orbital can accommodate electrons with azimuthal quantum number L is equal to 0. I will come back with these quantum numbers. And these orbitals present in every orbit starting from the first orbit. It is a spherical in shape. It is 1s, this is the nucleus beta, this is the nucleus, and it is 1s maximum probability is here. And here nucleus, and it has a 2s orbit, 1s orbital, and it is 2s orbital. Between these two node, n is said to be node. Node orbital where the probability of finding of electron is maximum is called orbital, while node is the probability of finding of electron is 0 is called a node. You understand? Clear? And it is going to be 3s orbital, 1s, 2s and 3s. Here it is going to be node. And these nodes are said to be spherical nodes because it is spherical in shape, nodal regions. So, spherical nodes. That is, sphere has a radius. They are also said to be radial nodes. So, number of radial nodes or spherical nodes is equal to n minus L minus 1. You can see there is no spherical node. There is one spherical node and two spherical nodes are there. You understand? And you have another one, nodal plane. And just want to show you the p orbital here. This is the nucleus and it is going to be a p orbital over here and it is a dumbbell shape. And there is a plane which pass through the nucleus where the probability of finding of electron which is maximum is called as nodal plane. So, this plane has angle. In node is a space where the probability of value of radius is not possible by the Bohr's radius. Yes, it is possible. Okay, of course, exact point you don't get it. Okay, okay. This is the nodal plane, or also it is said to be angular node. Number of angular nodes is equal to its azimuthal quantum number. Total nodes is going to be n minus L minus 1 plus L is equal to n minus 1. Got it? So, like that it is very simple to handle. And shapes of orbital, the total number of peaks appearing on the curve of s orbital is equal to n. Yes, it is probability density versus the radius. It is going to be exactly, it is for 1s orbital. And for 2s orbital, you can see 1s orbital. So, this is a psi. Psi for 2s orbital, negative bhi ho sakta hai. Psi for 3s orbital, positive, negative and positive. And you can see psi square for 1s and psi square cannot be negative. It will be always positive. Psi square is equal to 2s and 2p orbital is like this. Now, I just want to show you here, probability density on the same graph I want to give you. So, it is the radius. Okay. So, let us see here for 1s, this is the graph for 1s. For 2s, For 2s, it is coming like this. So, as the n value increases, peak of the curve increases. Or 3s, it is going to be like this. And you can say 2p बीच में आना है. Understand? So that I just want to show you the various orbital structures, my dear children. This is the one S orbital which has a spherical shape. It has spherically symmetric. Okay, you don't have any directional properties. This is all about the S orbital. You like it? You got it? Fine. Any doubt? Now let's talk about the p orbital. So the p orbital is a double dumbbell shape, and there is a distinct gap between the orbital to orbital, lobe to lobe here, and here this is a nucleus and it is a lobe. This probability finding of electron is there along the x-axis, is called as a px orbital. And you can see py orbital, the electron lobe is present on this pz axis, and py, this is the nucleus. Now you can see this is x axis, and you are going to see the nodal plane in this z axis, nodal plane in this z axis, right? And you can also see nodal plane on this y axis as well, nodal plane on this y axis as well. So you can identify the plane, Are you getting or not? Clear? Let's talk about the d orbitals. D orbitals has dx, dy, dz. So for the d orbital, I just want to show you the simplest way. So d orbital has 5 orientations. So they have dxy, dyz, dzx, dx square and y square, and dz square. Okay, let us draw these structures. So everybody can see this is orbitals. So let us see the lobes over here. dxy orbital is going to have a double dumbbell like this, and double dumbbell like this. And these three looks same only. Nodal planes are perpendicular to the direction in which the lobe is present, and the p orbital exactly Virat. Okay, so how to differentiate these two? Just name of the axis x and the y, and y and the z, and z and the x. Understand? That is the simplest way. Are you getting or not? Clear? And x square, y square, x and y, you are going to see on this x and y. So these are the three orbitals dxy, yz and zx are present. The lobes are present on between the axis, while here lobes are present along the axis, and z orbital g square is going to be like this, and there is a collar around it, and everybody has two nodal planes. For dxy, you are going to see a nodal plane here, nodal plane here, nodal plane here, nodal plane here. dz square also has a nodal plane. Cone shaped nodal plane can be seen. Two cone shaped nodal planes can be seen over here. Understand? Clear? So if you have any doubts, you please let us know. That is called collar. Yeah, this is called collar. My dear students, this is called collar. It is named as a collar. Right? Any doubt? So this is the orbital appears to be dxy orbital, so that it is going to be x. It is going to be x and y axis. The lobes are present in between the axis, right? And also exactly, and it is going to be dyz orbital, so that this is an x axis and y and z axis are there. The lobe is present between the axis. Okay, and also you have dzx orbital. Again, the lobe is present between the axis, and also d x square y square. You have the lobe is present along the axis. Understand? Any doubt? That's fine. Now the f orbital shapes is quadri-dumbbell shape. You need not have to worry about this quadri-dumbbell shape, how we learn it. And it has 5, s orbital has only one orientation, p orbital has 3 orientations, 5 d orbital orientations are seen, and f orbital has 7 orientation. Each orbital can accommodate a maximum of 2 electrons only. So double in its z square, exactly. And moving ahead, quantum numbers, this is very important. You are going to expect a question from there. So let's talk about the quantum numbers. So to characterize the electron, to identify the electron in an atom, we need a set of 4 quantum numbers. Okay, they are principal quantum number and azimuthal quantum number and magnetic quantum number and the spin quantum number. And these quantum numbers are very important, and only principal quantum number, that is n, and azimuthal quantum number L and magnetic quantum number m is related to this Schrödinger wave equation that is given as NLM. Okay. So if question is given psi 420, it indicates that n value is going to be 4, L value is going to be 2, and m value is going to be 0. Okay. So that 4d orbital. So we'll go ahead with this quantum numbers. Principal quantum number, it is designated by n, and this quantum number introduced by Niels Bohr. Whatever you study about the Niels Bohr comes under this category only. Every information is explained here in the basis of principal quantum number. And to explain the line spectrum, so the formation of various spectral lines in the hydrogen atom is explained on the basis of this principal quantum number, and it is nothing but your Bohr's theory. And it signifies to which shell an electron belongs. Principal quantum number 1, it is said to be shell number 1, K shell, 2, second shell, 3, third shell, K, L, M, N shells, like that. Okay, understand, my dear children? And it also signifies the size of the shell and the energy electron and the quantization of angular momentum, and also it is maximum number of electrons can be given as Bohr-Bury principle, that is 2n square. K shell you can have maximum of 2 electrons, L shell you can have maximum of 8 electrons, M shell can have maximum 18 electrons, N shell can have 32 electrons. It successfully explains this line spectrum of hydrogen, Lyman, Balmer, Paschen, Brackett, Fund series. And it fails to explain the fine spectrum of hydrogen. When the hydrogen spectrum is observed under microscope, it is going to show the small internal lines in it. To explain that, azimuthal quantum number is shown. That is azimuthal quantum number or subsidiary quantum number, orbital angular momentum quantum number. That is given by Sommerfeld. This is given by Sommerfeld. So, he said that electron is present in a shell, explained by Bohr, so that a line spectrum is observed. In that line spectrum, small lines are seen. So, there may be some sub-shells in a shell. So, that is why sub-shell quantum number is given by Sommerfeld or subsidiary quantum number. According to that, it is given as orbital angular momentum. It is going to be root over L into L plus 1 of h by 2 pi is the orbital angular momentum quantum number. So, in this orbital angular momentum quantum number, so L value starts from 0 and maximum its values are going to be n minus 1. If L value is equal to 0, it is said to be S subshell. If L value is going to be 1, it is said that P subshell. If L value is equal to 2, it is said that D subshell. If L value is equal to 3, it is going to be F subshell. And if L value is equal to 4, this is going to be G subshell. Okay, in the fine spectrum of hydrogen, it is observed that sharp, principal, diffuse and fundamental lines. And these lines are given as S, P, D, F. And it determines the angular momentum of an electron in the orbital. Azimuthal quantum number signifies to which subshell an electron belongs. And these are the things I already said. It is a shape also described here. S is a spherical, P is dumbbell, it is going to be double dumbbell in the case of D orbital, and complex and quad dumbbell in the case of F. And also magnetic quantum number. You have Zeeman effect and a Stark effect. Splitting of spectral lines in strong external magnetic field is called as Zeeman effect, and splitting of spectral lines in strong electric field is called Stark effect. Zeeman effect and Stark effect is not explained by the hydrogen spectrum given by Bohr, but this magnetic quantum number explained that. Good afternoon, Altamash. Hi, Altamash. सर आंसर कैसे चेक करने पर 300 बन रहा है और कुछ नहीं मिलेगा क्या मुझे? नहीं, you can challenge it. Okay, you just cross check it, the key given by Sri Chaitanya Academy and Infinity Land along with the NTM. Okay, so this magnetic quantum number, this quantum number proposed by this Land and Zeeman effect and Stark effect is explained, and it is donated by M or ML. And this quantum number describes the behavior of the electron in the magnetic field and the electric field. It signifies the orientation of the orbital. Its values can be taken from minus L to plus L including 0. Okay, so the total number of orbitals that can be present in a shell is going to be 2L plus 1. मतलब 300 नंबर पे कोई गवर्नमेंट कॉलेज मिलेगा नहीं. 300. कौन सा स्टेट का है अल्तमाश? कौन सा स्टेट का? स्टेट? हाँ ऋतु, गुड आफ्टरनून. अल्तमाश कौन सा स्टेट का? आई फॉरगॉट योर स्टेट. अल्तमाश Do you have any reservation? Do you have any reservation? यूपी ओबीसी में हाल तमाश मुश्किल है बेटा, मुश्किल है, difficult. Okay, so the total number of orbitals in a subshell is equal to 2l plus 1 beta, and magnetic quantum number signifies the orientation or the direction of the orbital. That's very important. Rutu, have any doubts? And said to be अगर सबशेल S होने तो L वैल्यू 0 हो सकता है, इसका M वैल्यू 0 हो सकता है, and so that you can have M means only one box. If L value is 1, M value can be like you see, it was a 0 here, it was a -1, 0 and a +1. If it is a D, it will be like this. It is going to be -2, -1, 0, +1 and +2. It goes like this. So 5 orientations. सेमी गवर्नमेंट कॉलेज मिलने का हाँ हो सकता है, chances are there. Okay, chances are there. You can just hope for it. Okay, है ना ऋतु एंड अल्तमस? अगर कुछ डाउट है ना तो पूछना बेटा. And here talking about the spin quantum numbers. Spin quantum number describes about the spinning of electron about its own axis. So it is going to be given as if the electron is revolving around the nucleus in about its own axis in a clockwise direction. So S value is going to be +1 by 2. If the electron is revolving about its own axis in the counterclockwise, it is going to be -1 by 2. Okay, so that we can say it signifies the spinning of electron about its own axis. And also it says the electrons that have different ms values are said to be opposite spins. I mean to say this is opposite spins. One is a clockwise direction, another one is a counterclockwise direction. एक्सपेक्टेड रैंक तो 2 लाख से अंदर है. ओके, रैंक प्रेडिक्टर चेक किया तो ओके, इसका हिसाब से जाना पड़ता है बेटा अल्तमाश. ओके, और एक बार ड्रॉप लेना चाहता हूं क्या अल्तमाश? बोलो, आपका मर्जी से कर सकता हूं, लेकिन आपका ड्रीम मेडिकल कॉलेज में जाने को कुछ मेहनत भी करना है ना? हाँ बेटा. Good afternoon Ritu. Now talking about the two values are equal magnitude but opposite in direction over here, है ना? Now they are represented by upward and downward arrow marks, and the total spin of an atom is equal to n into 1 by 2. So if that is the spin angular momentum of an electron is given by root over s into s plus 1 dot h by 2 pi, that is called spin angular momentum, orbital angular momentum, L into L plus 1 by L into L plus 1 dot h by 2 pi. Okay, बस में कोई भी गवर्नमेंट मिल जाएगी, बस एक सीट चाहिए मेरे को सिर्फ एक सीट चाहिए. ओके, मिलेगा, मिलने का कोशिश करो. एंड सेमी गवर्नमेंट कॉलेज में मिलना है. Punya. Okay, talking about spin only magnetic moment of an atom or ion is given by magnetic moment root over n into n plus 2 Bohr magneton, where n is equal to number of unpaired electrons, my dear children. So if the magnetic moment nu is equal to 0, it is said to be diamagnetic. Okay, if mu is not equal to 0, it is said to be paramagnetic. When a substance is placed on the external magnetic field, it is deflected or attracted towards the magnetic field is said to be paramagnetic. If that substance is not deflected, it is said to be diamagnetic. If the substance has unpaired electrons in it, it will be having the magnetic moment, such substance electronic configuration, it could be atomic or ionic or molecular level. It is said to be paramagnetic substances. If not, it is said to be diamagnetic substances. Okay. फी कितना होता है सर? We don't discuss about the fee because we don't want to encourage the commercial activities on the YouTube platform. That's the reason why I don't want to mention the fee as well, right? And but one thing you can say, sir, some Hindi language. हाँ, हार्दिक पुनिया हिंदी लैंग्वेज भी इस्तेमाल कर सकता हूँ. ठीक है. ये YouTube प्लेटफॉर्म में हम फीस डिस्क्लोज करने का, फी कमर्शियल एक्टिविटीज़ प्रमोट करने का मना है रूल्स का हिसाब से. ठीक है बेटा. टॉकिंग अबाउट द स्पिन ओनली मैग्नेटिक मूवमेंट इज हियर एंड टॉकिंग अबाउट electronic configuration of multi-electron species, we have the NLX method. I'll tell you, for a single electron species, when you write the electronic configuration for multi-electronic species, आप ऑफ-बाउ रूल इस्तेमाल करना, हुंस रूल इस्तेमाल करना, पाउलिस रूल इस्तेमाल करना. फॉर ए सिंगल इलेक्ट्रॉन स्पीशीज सिर्फ आपके लिए एनर्जी देखना पड़ता है. 1s ऑर्बिटल इज लेस देन 2s ऑर्बिटल, 2p ऑर्बिटल दोनों बराबर होगा एंड 3s ऑर्बिटल इज इक्वल टू 3p ऑर्बिटल इज इक्वल टू 3d ऑर्बिटल इज लेस देन 4s orbital, 4p orbital, 4d orbital and 4f orbital. So this is the strategy to say this single electron species. For multi electronic species, Euler diagram का हिसाब से जाना पड़ता है बेटा. And let us see here. For multi electron species आप ऑफ-बाउ रूल इस्तेमाल करो. ऑफ-बाउ ये जर्मन लैंग्वेज का वर्ड है. So building up. So it says during electronic configuration for multi-electron species, yes, you say first lower energy orbitals are filled, then higher energy orbitals are filled in the ground state. Okay, for that we need to take this Euler. Lowest n plus L value orbitals are filled first, then higher n plus L values are filled. Affordable range होता, I don't have like that's why आपसे कोडिंग किया. ओके, सो एल्स आल्सो ड्रॉप लेना हो क्या मुझसे नहीं लेना है वाइज तो ओके. अरे और एक साल आप मेहनत करने हैं तो पक्का आपको नीट में अच्छा मार्क निकलेंगे बेटा. सो भरोसा नहीं है आपके ऊपर, आपका भरोसा रखना है. ओके बेटा. Now talking about for a Euler's diagram. So this Euler's diagram appears like this. It says 1s is filled, then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 4s, it goes on like this. So the filling of electrons will be in this order for multi-electron species. Bachcho. Okay. So for that Pauli's principle BM, no two electrons in an atom can have the same set of 4 quantum numbers. I mean to say, पाउली जो बोलना चाहता हूँ ये सही है, ये गलत चीज़ है क्योंकि ये दोनों इलेक्ट्रॉन का क्वांटम नंबर सेम होगा. You understand? That is the actual meaning of this Pauli's exclusion principle. And no two electrons in an atom can have the same set of the whole 4 quantum numbers. इसका क्वेश्चन दे exactly बेटा Altamas. And 2 electrons have the same values of n and L, m, but it differs with s. So the maximum capacity of a main energy subshell is equal to 2n square electrons and that of subshell is equal to 4l plus 2. NEET में एक बार पूछे थे वाला, NEET में एक बार पूछे थे. And also you can see Pauli's principle is useful in determination of the maximum number of electrons that can be accommodated in an orbital. So a subshell and a main shell. Okay, ये बहुत useful content का है. And also orbital cannot have more than 2 electrons. If 2 electrons are present in their spins should be opposite in direction. Thank you Ritu, thank you, very good. and talking about maximum number of electrons in a subshell, S में 2 होगा, P में 6 and D में 10, and it goes like that, F is equal to 14 and G is equal to 18. काउंसलिंग गाइड पर वीडियो बना रहे हैं, हाँ अल्तमस काउंसलिंग के लिए कल एक वीडियो बनाने का कोशिश करता हूँ. टॉकिंग अबाउट हुंस रूल. So while filling the degenerate orbitals, pairing cannot take place unless these orbitals are half filled. This is about Pauli's exclusion principle, and we discuss it today. Dual nature of matter and Heisenberg uncertainty principle and the Schrödinger wave equation and shapes of orbitals, nodal planes and orbitals, and we have discussed about multi-electron species, electron configuration, Aufbau rule, Pauli's exclusion principle and Hund's rule. बहुत सारा cover किया आज. Okay, so you like this session? Rito, Altmas, Hardik. Okay, so please like this session and share with your friends and subscribe to Infinity Land NEET YouTube channel. Thank you very much. Signing off, Suresh, Faculty of Chemistry. Thank you.